Thank you so much for joining this lesson. We're going to discuss Mokasa 2, Mathematics Paper 2, the Section 2. Therefore, the Section 1 has already been covered. So if you've not checked this program, kindly find some time and see the discussion in the Section 1, which has been done thoroughly in this particular program, that is a Shifting Grades Online School. So please find your time and see the content that we are uploading in preparation for the Kcse 2025. So this time around now, we are going all the way to the section 2. So the first question on statistics, which is number 17, the question says that the table below shows the heights in meters of seedlings in Mr. Wanjala's seedbed. Part A, use the information above to complete the table below. So we have the height in meters, which has been put in classes. Then we have the frequencies in that particular class, the number of trees or the number of seedlings in the particular classes. So the first thing is to identify the midpoint. If you need to identify the midpoints, you're supposed to add the limits and you divide by 2 for every class. So that is the first thing that we are doing. We fill the table first. So the first limit, 0.01, plus the upper limit, 0.04. Then we divide by 2. We get 0.25. 0.25. The next one is 0.05 plus 0.08, and we divide by 2. We get 0.065. The next is 0.09 and 0.12. So we add and divide by 2. That gives us exactly 0.105. Then 0.13 plus 0.16, and we divide by 2. That gives us 0.1. That gives us 0.145. And the next is 0.17 and 0.20. We divide by 2, 0.185. And finally, 0.21 plus 0.24, then we divide by 2, 0.225. So that's how we get midpoints. You just add the limits and you divide by 2. Yeah, that is it. So we are through with the first part. The second part, we are getting a T. And how do we get T? T is gotten by 1,000, which is a constant, times every midpoint. Then we subtract a certain constant here, which for this case I would say is the assumed mean, 105. Then after subtracting, we divide by 40 everything. We divide by 40, yeah. So now we can get T in all the values. Something that we're supposed to know is that you see in the first case there is a blank. So we need to know that we need 1,000 multiplied by the midpoint in this particular case, which is 0.025. Then we will subtract 105, and after that, we divide now by 40. Then you just go to your calculator and you substitute that value very carefully. 1,000 into 0.025. Then we subtract 105. Then now everything divided by 40. We get -2. So you just operate with your calculator very carefully. The last one, we do the same, 1,000. So we write 1,000 into 0.225. Then we subtract 105 and we divide by 40. I'm getting +3. Yeah, it's +3 like that. +3. Then after that now, we are supposed to multiply every frequency and the T, the deviation. 12 by -2, we get negative 24. 17 by negative 1, we get negative 17. That's a 0. Then 28 by 1, we get 28. Then lastly, in the last bracket, we're having 3 by 9, we get 27. Yeah, we get 27 like that. So the summation of ft can be found. It's good we do summation of f of t. We add negative 24, negative 17, plus 0, plus 28, plus 46, plus 27. That gives us exactly 60. Yeah, that gives exactly 60. Right at this point. Like that. The next one is a t squared. So that we multiply now. So that we multiply f t squared. So when we square t, this shall be 4 because it's negative 2 squared. This is 1, 0. 1 squared is 1. 3 squared is 9. We are through with that part. So f t squared. Each part in t squared should be multiplied by f. For example, 12 by 4, 48. 17 by 1, it remains 17. Yeah, it remains 17 like that. Then 0 by 31. Then you go to 1 by 28, which is just 28. 4 by 23. 4 by 23 is 96. No, 92. Then 9 by 9. Frequency is 9. Then t squared is 9. So 81 at that point. This means we can also add f t squared. So summation of f t squared equals to, when we add everything, we get to 26. That is a 48 plus 17 plus 28 plus 92 plus 81. That gives us 226. Yeah, 226. That way, 226. Using the completed table above, determine part 1, the mean height of the seedling. We know that generally, mean is usually given by assumed mean plus the mean of ft. This is now naturally when there is an assumed mean and we get deviations from the midpoints. But now in our case, something that we are supposed to understand is that the assumed mean together with the deviation have been divided by a certain constant there. And also the midpoint has been multiplied by 1,000. Therefore, for us to get back to the values that we had, without that, we would have multiplied, we would have worked with very little values. So we need to talk about, because of multiplying by 1,000, we should divide by 1,000. And because of dividing by 40, now we multiply by 40. So we should be having our constants now being taken as the reciprocal. So we have the assumed mean as a 105 out of 1,000. Then we add summation of f of t should be multiplied by the constants that we add, but this way, 1,000 and 40 to change their positions like that. I'll be explaining that more. This is 60 out of, how many seedlings do we have here? Summation of f. We can check the CF column here, whereby we start with 12. Then the next will be 12 plus 17, 29. 29 plus 31, 60. 60 plus 28, 88. 88 plus 23, that gives us 111. 111 plus 9 get 120. Therefore, this is 120. So this is a value which had been multiplied by 1,000 and divided by 40. So to get back to the original value, we are supposed to reverse that step now by multiplying by 40 and dividing by 1,000 step. So now this is 0.105 plus, when we compute this, which is 40 by 60 over 1,000, getting 0.02. Is it so? 0.2. So this is going to be 0.125. That is the mean height. That is the mean height. Then we proceed to standard deviation. Something that you're supposed to know is naturally standard deviation. Standard deviation is given by the square root of variance. So the square root of summation of f of t squared out of summation of f. Then we subtract summation of, we multiply by summation of f of t out of summation of f, and this part should be squared. But now that in this case, we had multiplied by 1,000 and divided by 40 at this point. We multiplied by 1,000 and divided by 40. Then now we should multiply by 40 and divide by 1,000. So the constant which has been applied, we should now have it as the reciprocal 40 over 1,000, and we square this part. Yeah, 40 over 1,000, and we square. Therefore, the constants that we applied should also be introduced at this point, and we square them also. Yeah, and we square like that. Or simply, actually, so that we don't complicate, let's get variance first. Yeah. So naturally, this would have been variance, but now we should multiply it by the constants squared. So this is 1 over 625 into 226 out of 120 minus 60 over 120, but this part has to be squared. So this gives us 1 out of 625 into 32 over 15, giving us 32 out of 93.75. Yeah, 93.75. At this point now, we're supposed to say, because this is our variance, now the standard deviation will be the square root of variance, which is the square root of 32 out of 93.75. And this is going to give us a variance of, okay, a standard deviation of 0.056096. That's now the standard deviation. That is strictly according to the formula. According to the formula. Then part C, we are taught to determine the probability of the number of seedlings whose height exceeds 0.142. The height exceeds 0.3. So we will talk about, we talk about this number. Okay, this height being equal to, according to, we want to check the number of seedlings with this height. the number of seedlings with this height. So this height will be given by, where does the height lie? 0.142. 0.142. 142 shall lie here. So this is the class we want. So what is the lower boundary in that class? The lower boundary shall be 0.125. Lower boundary 0.125 plus total frequency. Okay, we can have a known number minus cumulative frequency before this class. So the cumulative frequency before this class, you know, the class is this one. So below this class or before this class is 60. So we'll be having 60 at that point. Then divide by frequency of this particular class. The frequency of this class is 28. Then we multiply by the class length. So the class length in this case is going to be, class length is going to be 0.04. Yeah, 0.04. So we can take 0.142 minus 0.125. This is 0.017 equals to n minus 60 out of 28, 0.04. Yeah, like that. How will you remain with, or we can divide through by 0.04 first to get 0.425 equals to n minus 60 out of 28. We can also multiply by 28 both sides, so that we have n minus 60 equals to, when we multiply this by 28, we are getting 11.9. So n equals to 71.9, which approximately means 72. 72 seedlings. 72 seedlings. These are the seedlings which are between 0 and 1.42. The seedlings between 0 and 1.42. Therefore, if that is the number of seedlings, between 0 and 0.142, then we can say the ones above that shall be total 120 minus 72, giving us what? Giving us 48. So 48 of the seedlings are now the ones above 0.142, meaning that we can find now the probability, and it shall be 48 out of 120. So 48 over 120, this is going to be 2 out of 5 when you simplify. 2 over 5. So that is the probability that we needed in this particular question. It's a very involving question on statistics, and we ought to be very careful for us to work it out. Number 18. Taking the radius of the Earth, capital R, is 6370 kilometers and pi, 22/7. Calculating part A, the shortest distance in kilometers between two cities, P, 60 north, 80 W, and Q, 60 north, 100 in the east. These are two cities which are on what we call a supplementary longitudes. Supplementary longitudes. This is 60 in the north. Then we are having 80 in the west, or we can start by 0 degrees prime meridian, 0 degrees equator. So we're talking about at 60 north, we have 80 in the west, 80 in the west, and 100 in the east. 100 in the east. Therefore, 100 in the east and 80 in the west are what we call supplementary longitudes. And this is how they behave. From one point, for you to get the shortest distance, you usually pass through the pole, the nearest pole. So if the two places are in the northern hemisphere, as you can see, the nearest pole is the North Pole. So through the North Pole, then down through the same path, because when two longitudes are supplementary, the path is usually the same. When you access the North Pole, this is the North Pole. When you access the North Pole through 80 degrees in the west, then you flow down, you will be automatically passing through 100 degrees in the east. In case you flow to the north using maybe 120 degrees in the west, once you pass through the north, you shall proceed to the east using 60 degrees in the east. So the route is just the same. When you pass through the poles following a certain longitude and you fail to change your route, you just continue flowing. You are always accessing the path which is in the supplementary longitude. Therefore, if that is so, then it means we need to agree at this point and say, because the shortest distance is the distance across the pole. If this is 0 equator, then we measure 60 degrees, then on the other side, we also have 60 degrees. We measure 60 degrees to Q, 60 degrees to P. But now the plane shall be moving now from this point across the North Pole to this other point. So this is Q, this is P. This is a great circle. What is the angle at the center? It shall also be 60, because we are already having 120. The remaining angle there shall be 60. So along a great circle, and the angle at the center is 60. We see the distance in kilometers along a great circle is given by the angle difference out of 360, 2 pi r. 2 pi r. So 60 over 360, 2 pi r. So what we get here shall be the distance, and this is going to be exactly 6673 and a third. Kilometers. Yeah, 6673 and a third kilometers. So that is it. Number 18B. An airplane flew from P at 12 hours local time to Q along the parallel of latitude at a speed of 1,001 kilometers per hour. What was the local time at Q when it arrived? So we first of all find the distance. This is distance in kilometers along a small circle, or rather along parallel latitude circle. That means the distance will be given by the angle difference over 360, 2 pi r, the cosine of the latitude where the two places are. So the angle difference, when we follow the parallel latitude from 80 in the west all the way to 100 in the east. You know, this is the kind of a circle now that we are tracing. The kind of a circle now, not through the pole now, but through. So we are moving from P all the way to Q. Then from the equator or from the prime meridian, we are having 80 and 100. So we are having 180 as the angle at the center of this circle. So the small circle is having 180 at the center over 360 to pi r cosine of 60. Yeah. So the angle there is 60. And the total distance that will be covered is going to be 10,010. 10,010 kilometers. So what will be the time taken in this case? Time taken is equals to distance out of speed, which gives us it's going to give us 10 hours. So it shall spend 10 hours. Yeah, 10 hours. Then now we will say this. The airplane began the journey from P when it was 12:00. Then we ask ourselves, at the time when it was 12:00 at P, what was the time at Q? You know, Q is in the east. So Q is ahead in time. Q is ahead in time. How ahead is it? How ahead is it? So we usually say this, that the 360 degrees are rotated within 1440 minutes. So how many minutes are required to go through 1 degree? So it shall be 1 times 1440 over 360, giving us 4 minutes. So for every 1 degree, there is a 4 minutes time difference. What about for the 180 degrees between P and Q? 4 times 180, we get minutes, so we can divide by 60 to get hours. This is going to be 12 hours. So there is a time difference of 12 hours. And now the point here is, point Q is ahead in time. If it's ahead in time, then we will say that, we say that when it was 12 in the noon, at P, at Q, at 12:00 hours in P, it was, this time corresponds to 12 plus 12, which is 00 hours. Therefore, when it was midday at P, at Q, the following day was starting. Therefore, now, if this was the time at Q, then the time it was arriving, we will add 10 hours. And this will be 10:00 hours the following day. 10:00 hours the following day. 10:00 hours the following day, which is 10 a.m. In other words, it's still 10 a.m. that way. It can also be written as 10 a.m. The statement about the following day is very key. The following day is a very key statement. In case we'd been told an airplane flew from P at 12 on Monday, then we would have said that this particular 10 a.m. now is for Tuesday. But now that the day was not specified, then we will talk about the following day. Very simple. Very simple work. Now we check we check question number 18C. The question says that the airplane then flew due south from point Q, which is 60 in the north, 100 in the east, to point B at speed of 194.4 knots. The distance covered by the airplane was 3888 nautical miles. Find the position of B and the local time it arrived at B if it rested for 30 minutes at Q in 12-hour clock systems. So at this point, we will say that it's going to fly due south. So from Q, it shall fly southwards. That means it shall fly along a great circle. We have the distance, but we don't know the angle it flies through. So we can get the angle because distance in nautical miles along a great circle. Flowing southwards means along a great circle, and a circle of a longitude, usually given by 60 times the angle difference 60. So a distance of 3888 equals to 60 times the angle difference, which is not known. So the angle difference shall be 38 over 60, giving us 64.8 degrees. So if there is an angle of 64.8 and we are going down from 60 degrees in the north, then it means we will cover the whole 60 degrees, which is to the north. Then we add 4 degrees, 4.8 degrees in the south. Therefore, this other point now, which is point B, B is going to be 4.8 degrees in the south, 100 degrees in the west. Is it 100 in the west? No, we are in the east. 100 in the east. 100 in the east. So you see, we are having the position of B. What else are we finding? The local time when it arrived. Remember, it was already 10:00, and now we are 10:00, sorry, hours, or 10 a.m. Then we are adding the 30 minutes for stoppages. Then we are also adding the time taken. Time is given by distance over speed. Distance out of speed. This will give us how many hours? This will give us exactly 20 hours. Then we add 20 hours. So this is going to be first before the 10 hours, the 20 hours, we can check 10:30. This is because of hours. 10:30 hours, this is because of the stoppages. But now we now add 20 hours which were taken for the journey. The 20 hours consumed in the journey. So 20 hours in the journey, it means we shall have, this is 10.5, and we needed 24 hours to finish the day. So we are remaining with 13.5 hours. 13.5 hours. So when 13.5 hours are added here, the day ends. So we need 13.5 hours to first finish the day, to completely finish the day. Then after the day has ended, remember all the hours were 20 hours traveling. And we've just fixed the first 13.5 to finish the day. So how many hours are yet to be traveled? 20 minus 13.5, we're getting 6.5 hours. Therefore, from midnight now, we are adding 6 hours and half. This is 06, 30 hours. This can also be given as 6:30 a.m. the following day. The following day. So thank you so much for following. Actually, this is a very interesting question. I hope you've understood how to approach such a setting. It is a very serious setting on time the following day. So that is it. We now check the next question. Complete the table below, correct to 2 decimal places. We are supposed to adhere to instructions of the decimal places. Even though the examiner has filled some of the coordinates in 1DP, you are not evaluating the examiner is evaluating you. So you're supposed to be very keen in that. Don't be carried by what the examiner has written. Just follow the instructions up to the letter. Follow instructions up to the letter. As we turn to number 19, allow me mention something about our programs here, whereby we have the day scholars programs here. For every weekend, we have a program with the day scholars. So please join us for our serious programs here via Google Meet, very interactive. So you can confidently join us and get the best from our programs. Our number is already attached on this screen, 0704 15 3366. Reach out for more consultations about our programs. Then we have the November-December holiday program. We call it the one-term ahead program, whereby you'll be opening for term 1, 2026, when you have already been introduced to the term's work. So you can join for our programs so that you get the best. Our target groups are for grade 7s, 8s, and 9s, then Form 3s and 4s. Still interactive programs via Google Meet. Kindly register and get more information about our programs. So now we are going to start with filling the table first. -2, you just type it in the calculator into -2 into, or -2 cosine of, you open brackets, 2 multiplied by the first value of x, which is 0. So I'm getting -2. When I get -2, I write it as -2.00 because of the 2DP, 2 decimal places. So you should focus on safeguarding your marks. Then at 45, we're supposed to have, we again write -2, the cosine of 2 multiplied by 45. That gives us exactly 0. So this is going to be 0.00. The next is 60. So -2 cosine of 60 times 60. No, 2 times 60, sorry. 2 times 60, which is our x. So I'm getting 1. So it should be 1.00. At 75, you type in your calculator -2 cosine of 2 multiplied by 75, right? Yeah. That would be -1. Okay, positive 1.73. 1.73. That way. At 90, it's failed. We go to 105. So -2 cosine of 2 times 105, giving us 1.73. We proceed to 135. At 135, you'll be having -2 cosine of 2 by 135. This will give us 0. So we will have it as 0.00. Yeah, that is done. We go to the next function, which is 3. The sign of, we open brackets, 2 times 0. Then we add 30 and we close brackets. This is giving us 1.5. All right, that was already done. We go to 15. You type 3, the sign off, you open brackets, 2 times 15, then you add 30, and this is giving us 2.60. It has to be 2 decimal places. 3, the sign off, you open brackets, 2 by 30, then we add 30. This is giving us exactly 3. So it will be 3.00. At 45, this will be 3 sign. 2 by 45, then plus 30. We're going to get 2.60. Then at 60, 3, the sign off, you open brackets, 2 by 60 plus 30. 1.5. So we'll be having 1.50. We introduce a 0 at that point, just to ensure that the accuracy is sustained according to the examiner's demand. We go to 3, sign, open brackets, 2 multiplied by 90 plus 30. This gives us negative 1.5. Is that right, yeah? Negative 1.5. So we introduce a 0 for 2dp. Then 3, the sign off, 2 multiplied by 105 plus 30. This gives us negative 2.60. Then at 120, we'll have 3 sign, 2 by 120 plus 30. Yeah, 2 by 120 plus 30. It gives us negative 3. So this will be negative 3.33. Then we proceed all the way to 165, where we have another blank. So we talk about 3, the sign off, 2 multiplied by 165 plus 30, 0. So this is 0.00. And finally, at 180, we'll have 3 sign, 2 by 180 plus 30. This is 1.5. 1.50, like that. You see? So we have the table already filled by simply using your calculator and typing the right thing in the calculator. Then we proceed to part B, which bears 5 marks for this case. That's why I'll continue encouraging learners and students who are doing the Kcse to always prefer graphical questions. Look at the first 7 marks. You are just going to use your calculator, then the plotting skill. Without even struggling to reason, you are already having 7. So let it be known that graphical work can be embraced and you get your marks very easily. So I'm going to start by the x-axis and the y-axis. So I plot that first. The y-axis is here. Then the x-axis. We have it here. Like that. This is 0. We've been given some instructions on the scale to use. We are told this. Using a scale of 1 centimeter for 15 degrees on the x and 1 centimeter for 1 unit on the y. So on the y, we will have 1, 2, 3, negative 1, negative 2, negative 3. Then for the x, 15. So this will be 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180, that way. Those are the intervals that the examiner is demanding for. And on the same axis, draw the graphs of y equals to -2 cosine 2x and y equals to 3 sine 2x plus 30, ranging between 0 and 180. So we first plot the first curve, we finish up with it, then we get to the second curve. Allow me choose a conspicuous color here for the coordinates. 0, -2. So 0, -2 shall start here. The next one is 15, -1.7. 15, -1.7. 1.7 should be, remember, that is just 1. So 1.5, 1.7 is 1.8. 1.7 will be at some point there. Yeah. Then we go to 30, -1. 30, -1. 45, 0, 0. 60, 1. 75, 1.75. So 1.75 will be here. Then 90 and 2. 90 and 2. 105 and 1.75. 120 and 1. 135 and 0. 150 and -1. 165 and -1.7. Then 180 and -2. 180 and -2. So those are the coordinates. We can join them to come up with the graph. So now we join using a very smooth curve. They're very smooth. It's my hope that you can see how the curve is curving. You can see the smooth curve. Yeah, like that. So that's the first curve. That is the first curve. And it is curve y equals to -2, the cosine of 2x. That one. Then the other one can also be plotted. The other curve can also be plotted. So we'll be having the coordinates. Let me begin with the coordinates. So we'll start with 0, 1.5. So 0, 1.5 is here. Then 15, 2.6. 15 with 2.6 should be there. 30 with 3.0. That is the coordinates. 45 with 2.6. Then 60 with 1. 60 with 1. 1 is already identified. 75 with 1.7. 75 with 1.5. 60 with 1.5 should have been here, sorry. 60 with 1.5. Then 75 with 0 here. Then 90 with -1.5. 90 with -1.5. 105 with -2.0. 2.6. So 2.6 shall be there. We also talk about 120 with -3. 135 with -2.6, which is here. 150 with -1.5. So -1.5 shall be here. 165 with 0, 0. That is the point. and 180 with 1.5. So 1.5 shall be at that level. So you see, we are having the coordinates showing the curve, and we can join them smoothly to come up with the second curve. Yeah, to come up with the second curve. Look at the curve. Very smooth curve. And this is what I expect in your work whenever you are plotting yours. This is the kind of a curve that you also supposed to come up with in your book. I'm just using my freehand. Just using my freehand. And that is what you should also come up with. So whenever you are coming up with a curve, ladies and gentlemen, I expect it to be this smooth, equals to 3 the sine of 2x plus 30. That way. So we have the first 7 marks properly plotted. So that is it. Then now we have a part C here, where we are told to use the graph above to solve the equation 3 the sine of 2x plus 30, then plus 2 the cosine of 2x equals to 0. In other words, the first function is y equals to 3 sine of 2x plus 30, and the second one is negative 2 the cosine of 2x. So with it this way, this part has been taken to the left to be positive and remain with 0. But when we split them now and take it to this side, you can now see that we need the second function and the first function are equal. So when is the first function equal to the second function? It is at the point where the curves are meeting. So at the points where the curves are meeting, we can read the values of x there. We can read the values of x there. So the values of x are going to be at the points of intersection. We identify the points of intersection. So what are the points of intersection? One of them is here. One of them is here. So that is a 60 what? You know, five squares. 5 squares are representing 15 degrees. What about one small square, which will represent 15 by 1/5, which is 3 degrees. So one small square is representing 3 degrees. So that is going to be 63. So x equals to 63 degrees, and x equals to another point of intersection is here. Another point of intersection is here, whereby this is going to be 153. 153. So that is how we solve the first part. Remember, we are remaining with only one mark, and the last mark for this case. Find the range of values of x for which 3 sine 2x plus 30, this is the second function, is less than or equal to the second function for the first one. Yeah. When is the second function greater, or what is the range of values when the second function is less than or equal to the first one? So the range of values is the range of values of x between when the two curves are equal. Therefore, the values of x are going to start from 63, then they end at 153. That is the range within when the two curves are either equal or the second one is greater. So that is the range we give. We can proceed to number 20, which is a question from a three-dimensional geometry. Three-dimensional geometry, very interesting question in this case. So we read the question together. In the figure below, a triangular prism is placed on top of a cuboid. Point K, as you can see, and J lie vertically above line AD. Vertically above line AD and line BC respectively. As you can see, AB, the length, equals to KJ, and that is equal to 18. Let me indicate 18 centimeters. Also, this is 18 centimeters, meaning that this is also 18 centimeters. This is also 18 centimeters. We have very many 18s here. 18 centimeters that way. BC equals to 12. This is a cuboid, remember? So if this is 12 centimeters, then up here we have 12, and across here we got 12, and up there we have 12 centimeters, like that. What else do we know? CH equals to 10. This is 10. Okay, these are meters. Sorry. These are meters and not centimeters. Sorry, I've indicated the wrong unit at the right values. They are meters and not centimeters. Yeah, like that. They are meters, 10 meters. So this is also going to be 10. This shall be 10. This shall be 10. That way, what else are we given? FK equals to KE. So this length and this one are equal, and also equal to JH and also JG. That way. Those are equal lengths. We proceed. N is the midpoint of BC. We can see N as the midpoint, meaning that BN is 6 and NC is also 6. That is now some of the interpretations that we're supposed to make on the diagram, even before we proceed to the questions. Then now we can get to the answering of these particular questions. Calculate part A. The height of the ridge, KJ. Height of the ridge, KJ. So the height of the ridge means from the base to where KJ is. I hope you understand that. Yeah, from the base to where KJ is. That is what we need to work out. Therefore, we can first deal with one of the triangles. Let's say JHG. JHG. So that we talk about. Let me extract it. Let me just extract it like this. So if we have a J, then GH, like that. This is 12. And then this one is equal to this one. That's what you're supposed to understand. Those parts are equal. Then we should be able to work out very comfortably the vertical height at that point. Yeah, the vertical height can be worked out. Maybe using some trigonometry. You can check. Using some trigonometry. Like that. Let me check where the 8 centimeters were. 8, 8, 8, 8. That way. We had not indicated the 8. So this is 8 centimeters. And after dividing, this becomes 6. Is it okay? Yeah. 6, 6. Then now we can say that 8 squared minus 6 squared, then we take the square root. We shall get the vertical height at that point. So this is going to be 8 squared minus 6 squared, then the square root of 28. The square root of 28. So this is going to be 5.292 meters, meaning that the vertical height of KJ from the base, the height of ridge KJ, where is it placed? That's going to be 10 from the base, because already, let me now show you the distance we're having. We need height Jn, height Jn. Therefore, from this point, which I can call X for now, from X to J, we are having this X to J, we are having 5.292. And from X to N, we are having 10. Yeah, we are having 10. Therefore, 10 plus 5.292. This is giving us 15.292 meters. That is the height of the ridge KJ. Perfectly calculated. Yeah, perfectly calculated. Then we check part B of this. This part B is telling us that the angle between line FJ and the plane EFGH. FJ, you can see FJ. FJ is a line from this point to the other across. FJ and the plane EFGH. EFGH. Therefore, we are supposed to ask ourselves, is the line casting a shadow on this particular plane? Yes, it can cast a shadow. So then the angle between a line and a plane is usually the angle between the line and its own shadow on the plane. A line and its own shadow on the plane. So it would cast a shadow like this. It would cast a shadow like that. So we are talking about the angle now. The angle like that. So that is the angle we need, and it can be worked out very fast. We can use very many methods. Yeah, there are several approaches. One, remember the angle is at F. So FJ, FJH, that's a triangle. FJH, I hope you can see that. If that's a triangle, then we need to observe. We need to observe all the sides can be obtained. All the sides there can be obtained. And if they can be obtained, then we can get that particular length, that particular angle can be found. So can we get FH? The length FH is going to be Pythagoras theorem. We need to take 18 and 12 squared. 18 squared and 12 squared, the square root. So this is going to be the square root, 21.63. 21.63. Therefore, the triangle now that we are talking about, say F, let me just show it to you. Let me show it to you. We need this angle. This is F. This is J. This is H. So this is 21.63. F to J. From F to J, okay, we don't have that length, but it can still be found. It can still be found. So let's know that first. This is 8. That's 8. So for us to find this particular length, which is a F to J, then we can still apply Pythagoras theorem and talk about 8 squared and 18 squared square root. Eight squared and 18. Yeah, 8 squared and 18. We get FJ. So we take our calculator and we write 18 squared plus 8 squared, the square root, giving us 19.70. 19.70. That's 19.70. So with that, or with all the sides, then we can find, with all the sides, we can find, with all the sides, we can find the angle at F, thereby saying 8 squared equals to 19.70 squared plus 21.63 squared minus 2 into 19.7 times 21.63, the cosine of the angle at F according to the cosine rule. So we square this, get 388. This is 64 equals to 388 plus, we square the other one, we get 468 minus 2 into, let me multiply that, 2 times 19.7 times 21.63, giving us 426. Yeah, 426.11, the cosine of the angle at F. Then with that now, we can group terms 64 minus 388 minus again 468, giving us -7. -792 equals to -426. Yeah, 46.11, the cosine of the angle at F. So cos F shall be, we divide this. There must be an error somewhere. Something not properly computed. I'm just confirming that right away. Yeah, we didn't multiply by 2. So that was 852 at this point. $852.22. This is 852.22. The negative will cancel. And now we'll be having 792 divided by this value, which is 0.9293. So that we get the angle at F, we get the cos inverse, shift cos. And this gives us 21.67. 21.67 degrees. Yeah, 21.67 degrees. That is the angle, 21.67 degrees. We proceed to the angle in part C. The angle in part C, we're told to find the angle between plane. The plane is a FEJ, plane FEJ. Where is that plane? Let's identify it first. Say FEJ. You mean the plane that is a sloping plane, F to J, then from J down to E. Yeah, down to E like that. So that plane we want, together with which other plane? EF, together with the plane FEJ with ABC. With ABC. One thing that you're supposed to know is that those two planes, FEJ and ABCD, are not meeting. If they don't meet, we translate one to the plane that contains the other. It should be very easy to translate the base upwards so that they meet somewhere. So when we translate the base, it becomes FGHE. So that is the angle we need now between the two planes. And how do we get the angle between the two planes? We are supposed to consider the angle that passes through the mid of one. So we do a line passing there. We draw it like that. Then now through the other plane, we also draw a line passing there. So that is the angle we need. If we have a plane like this and another one at the base like that, so we need the angle that passes through here and the angle that passes through the middle of this. So that's the angle we need. That is the particular angle that we need. For this one, we can use several approaches. One, this is right angled. Yeah, at this point, we have a right angle. The height here was obtained as the square root of 28. This is the square root of 28. Then the base at this point is 18. This is 18. So we need now to get the angle on the other side, which will need tan. The tan of the angle, which is unknown, tan of the known angle, that means tan of beta equals to root 28 out of 18. So for us to get beta, we need the tan inverse of root 28 out of 18. What do we get? Root 28 divided by 18, then shift tan, this particular, 16.38 degrees to 2 dp. 16.38 to 2 dp. That is what we need to understand. Yeah, that is what you need to understand. That is the angle that was desired. Then we can proceed to part what? We have a part D of this. Part D of this question says with angle between the plane FEN, FEN. Let me first identify, like in the work, so that I may see FEN well. FEN is a plane like this. FEN means from F to N. F to N, then from up to N again, like that. That is the plane, a triangular plane, which is sliding all the way from FE to point N. that plane and which one? And ABCD, the base. ABCD, the base. So the angle between these two planes now, if we identify the lines passing through the mid of each of the planes, like through this plane to the point where they meet, and also through the other plane, which is now the base, like that, then this is the angle we need. So for this particular angle, we have all the heights. This is 18, and the perpendicular height here, the perpendicular height there is 10. So how can we get this angle? Again, tangent. So the tan of a known angle, the tan of the known angle will be given by opposite out of adjacent. Opposite, because with the angle at this point, the opposite is 10, adjacent is 18. So we need now the angle by taking the tan inverse of 10 over 18. What does this give us? Tan inverse of 10 over 18. Shift tan 10 over 18. This gives us 29.05 degrees. 29.05 degrees. Then here we're having part C as we wind up. So part E, that is the angle between two lines, GC and AD. GC and AD, I clean up so that you may identify. GC and AD. GC is here. This is where GC is. Then AD is the base on the other side. AD is the base there. I think that is it, yeah? The two lines are not meeting anywhere. That means they are what we call skew lines. So with skew lines, we are supposed to translate one of the lines to the plane that contains the other. So if we translate GC, it will become FD on the other side. It shall become FD after translation. We just translate this one. We translate it to the plane that contains the other, and it shall become FD. So we need this angle at this point. This is right angled. AD, the length AD is going to be what length? AD. This is going to be 12, just like BC. Then the height here is going to be 10. So we can use what? Tangent again. The tan of the unknown beta, the tan of the unknown angle equals to 10 over 12. So the tan of the unknown angle shall be 10 over 12, meaning that the unknown angle shall be the tan inverse of 10 over 12. This shall give us what? Shift tan 10 over 12, giving us 39.81 degrees. So that's how we find the angles for that particular diagram, three-dimensional geometry. Remember to purchase your airtime through our model here. Just go to your M-Pesa, Lipa na M-Pesa. Then the pay bill number is attached on the wall. The pay bill number 737356, and the account number is the phone number that you're purchasing the airtime for. Then after that, now you can enter the amount, you complete the transaction, and you shall be receiving the airtime instantly. Otherwise, thank you so much for following. Remember to subscribe and to share with friends.